Winter brightness. So, good evening, everyone. We are here to talk about. I have with me Sagar Watrai, the sub leads of New Rupee teams. So he's gonna ask me a few questions about it, and this is just a Q&A session about the project. So good evening, Sagar. So start with the questions. Go on. So the thing is, the animal cruelty on the planet is going up really high, and the carbon emission from doing that literally it's killing the planet. For so we managed to lower carbon dioxide emissions by 82.55%. So it was calculated by us during the entirety of the project. So 9 days it was calculated how much CO2 was released, how much CO2 was used. So that's why we are trying to do it. So we are trying to decrease carbon emissions. We're trying to decrease the impact it has on the planet, and overall make healthy animal cruelty free meat. So any other questions? uh yes and no at the same time. So yes, the meat is sustainable if you use enough blood for it, but it's not sustainable if you don't have the culture size for it. So the thing is, the culture size of our original uh, cells were somewhere around 17, 18,000 cells. Uh, so it was somewhere around 2 milliliters of induced pluripotent stem cells. We could have grown it out to somewhere around a quarter of a billion, so somewhere around 50 million cells. Uh, we didn't do that at first. So we turned the induced pluripotent stem cells into fibroblasts and then turned it into uh, myoblast or muscle cells. So it could have been done. It is, yes, very sustainable actually, more sustainable than the current practices. It will technicality, no. By technicality, if we don't dump the waste, the fluid that has been used already into our wildlife or the river systems, waterways, it will not disturb the ecosystem one bit. It's very efficient. The thing is, there is a potential risk of causing new viruses or diseases, but it's very minimum actually. So it is very, very useful in the field of biotechnology. Not the part growing the meat, but the part of using a pre-prepared leaf instead of a microfluidics array. It's very useful. So if you have to create microfluidics array of that size with that of precision, it's really, really hard to do in the country like ours. So using a leaf which has already a ton of pre-built network systems is very good. Actually speaking, the cellulose and the lignin in the leaf helps our cells to grow attached to it, and overall we could grow neuron cells on it. We could grow fibroblasts, myoblasts, and a whole array of cells. It's actually very, very useful to humankind actually. So biotechnology. So the expected cost of it will go down eventually, but currently of now, so for 18 grams of meat, we needed 725 rupees, so somewhere around $5 to $6. So for 18 grams, is better than other alternatives of the same kind of meat, lab grown meat. So it's really good actually speaking, but it might go down to somewhere around 50 to 60 rupees per 10 gram of meat. So we could do that in the future. Hmm. Yes. So in summary, it's useful for the planet. It's useful for biotechnology. It's useful to advance biotechnology in Nepal. And plus of all, with it in a minimally secure, minimum facility, so it could be replicated elsewhere on the planet with below a minimum number of equipment. So it's really good. We might be the first on the planet to have attempted such a thing. So to use induced pluripotent stem cells, the proper facility has to be biosafety level at least at minimum biosafety level 2, but our facility was somewhere around biosafety level 1.5 or so. So it was kind of done for really cheap, but the outcome was really good, actually speaking. So the fluorescent microscope results were somewhere around 80% of the cells were alive at the end of the 11th day. So the project ended at 9, but we kept the cells growing until 11. So the 80% of the cells were still alive to 11th day when the fluorescent microscopy was taken, and even the dead cells were bound to the cellulose wall. So it's really good, really promising actually. So any further queries, Saga? So, so to simulate the environment of the womb of the animal, so currently speaking, we use rabbits. So Drosophila, so the fruit fly has the exact vaccines that is found in regular rabbit's womb. So we use that because it fit our specification perfectly. So the growth factors is actually a very funny story. So we try to extract growth factors from the blood, but it's nearly impossible. The growth factors are really low in an adult rabbit. We had to take the blood from a young rabbit to do so. So we didn't do that actually, but we stumbled upon a hair growth supplement that was listed as FCF7, so fibroblast growth factor 7, and insulin growth factor 1 on the internet. So people use it for hair growth supplements. So we used it from there, but we had to further refine it and purify it somewhere around 17 times. So it was somewhere around hour long process to purify the IZEFs, and for the FGF, it took us nearly 1.5 days to purify. So it's uh, it's kind of a complicated process, but it's cheaper than buying so growth factors on the internet that are recommended for biological things. And plus of all, it was edible, so it makes our project more or less very safe for humans to eat. So no carcinogens, no lead, no heavy metals were found. The pH level was perfectly fine. but the saline level was kind of high because we didn't use distilled water. We used saline as our uh, mixture, so our volume mixture. So we had a bit too much salt on the piece of meat, so the meat leaf. But gentle rinse, and plus of all, in future production, we are gonna use distilled water. That's why the problems are kind of self-solving as of now. So the further up of this project is, as you already know, Saga. So we are trying to grow neurons on a disk. So we are preparing for that. So there will be an upcoming live on that, plus of all. And speaking of that, as I already mentioned, Saga Watrai is now the new sub leads of New Ruby teams. So congratulations on that. And plus of all, a lot of burden is falling upon your head for nothing at all. But I think revolutionizing science is important for us all. So thank you all for tuning in today with this video. Please don't forget to like, subscribe, and help us out. So we don't have a Patreon, we don't have a GoFundMe. We live in Nepal. We don't have such facilities, but we can still earn from YouTube and still progress science with your help. Thank you. Have a great evening. Bye.